resistance, as the name implies, is going to resist that flow of electrons. So that's going to be measured in ohms, okay, and shown as this, as in the electrical circuit in the circuit diagram. I will have to say that's pretty awesome unit of measure in terms of, you know, where it comes from, Ohm's law. I'll have to say, let's be honest, 13 Garbinis, it sounds pretty good. Okay, so I feel like if I ever make something up and it comes to this, that's what I'm gonna roll with. I digress. Anyway, so what we have to determine is that we don't ever have, well, it's rare we ever have one resistance, right? You don't have one light bulb. Typically have like bulbs, Christmas lights, right? Everything's on that circuit. So what you have to determine is what is that equivalent resistance, because we only have one R in Ohm's law. So that's the idea, is we have to always come back to one equivalent resistance in order for us to determine what the current is or what the voltage is. So two types. This is how I denote the variables R equals EQ. So you have series, parallel. Series. The easiest way to describe this is a one-way street. You know you're going to start here if there is only one way to get to the end. Now it could be some crazy looking maze. As long as the lines don't cross, which is not, they're not going to, and you get back to the one-way series. That's as simple as you're going to get it. Okay? So, in terms of parallel, what we have is if you have more than one. It's pretty much is where that comes from. So, just like this, you come up and you have multiple ways to get back to it. So, a standard is one way for the series, multiple ones parallel.